Back, dear students, let's continue with the next theorems of quadrilaterals. In theorem 8.6 we have to prove that diagonals of a parallelogram bisect each other. What do you mean by bisect each other? It means that this diagonal AC and diagonal BD, they meet at a common point, they divide each other equally. Bisect each other means like the plus sign. Plus sign, what happens in the plus sign? Both the lines divide each other equally. This two will be equal and this two will also be equal. This is the meaning of bisect each other. So we have to prove that the diagonals of a parallelogram also bisect each other. So let's take a figure. ABCD is a parallelogram with AC and BD as its diagonals, and O is the point of intersection. So this AC and BD are called diagonals of a parallelogram. We have to prove they bisect each other, so I need to prove that OA is equals to OC and I need to prove OB is equals to OD. So if I prove this OA is equals to OC and OB is equals to OD, then we can say that they bisect each other. So for proving this, we can prove these two triangles are congruent, and we can say by CPCT that this is equals to this and the other part is also equal. So let's prove these two triangles are congruent. So for that, we know that opposite sides of a parallelogram are parallel, so we can say AD is parallel to BC. When AD is parallel to BC and this is a transversal, so we can say these two angles are alternate angles and these two are also alternate angles. Okay, these two are alternate angles. Yeah, two lines are parallel and there is a transversal, so we get alternate angles like this. So we can use alternate angles and prove these two triangles are congruent. So if AD is parallel to BC and with transversal as BD, I can say this ODA is equals to OBC, first point. Then in the same way I can say with transversal AC, with transversal BD, these two are equal, and with transversal AC, with this transversal, these two angles will be equal. Okay, so next step I will take that angle also. OAD is equals to OCB, they are also alternate angles. So we can use this to prove these two triangles are congruent. So you can see I have shaded the triangles which we have to prove congruent, the green colored and the blue colored triangle. So let's prove in triangle AOD and triangle BOC. You can see this OAD is equals to OCB, just now we proved it here. Then I can say AD is equals to BC because opposite sides of a parallelogram are equal. Then the other pair of alternate angles, this two. Okay, so I can say these two triangles are congruent by which rule? ASA rule. Two angles and one side of this triangle are equals to two angles and one side of other triangle. Okay, so now we have got these two triangles as congruent by ASA rule. So I can say that when these two triangles are congruent, OA is equals to OC and OB is equals to OD by CPCT. Hence it is proved that the diagonals of a parallelogram bisect each other. Now next theorem 8.7 is converse of 8.6. In this we prove that diagonals bisect each other. In the next theorem we have to prove that if diagonals of a quadrilateral bisect each other, then it is a parallelogram. This is converse of theorem number 8.6. So you can try this theorem in this by looking at the steps. Okay, all the steps I have given here. We have done so many theorems, so follow this congruency rules and prove this theorem. Next theorem, that is theorem 8.8. In this theorem we have to prove that a quadrilateral is a parallelogram. Okay, a quadrilateral becomes a parallelogram. ABCD is a quadrilateral here. We have to prove that this becomes a parallelogram if one pair of opposite side is equal and parallel. Okay, so what do you mean by this? If I have a quadrilateral with one pair of side equal and parallel, imagine these two are equal and parallel, So this forms a parallelogram. This is the least condition for a quadrilateral to be a parallelogram. One side should be equal and it should be parallel. Then it becomes a parallelogram. So let's prove this theorem now. Theorem 8.8. Let's consider a quadrilateral ABCD in which AB is parallel to CD and AB is equals to CD, because it's given in the question that opposite side is equal and parallel. Okay. So to prove this ABCD is a parallelogram, so we'll prove these two triangles are congruent. Triangle ADC is congruent to triangle ABC by using a suitable congruency rule. So I can say AB is equals to CD because it is given to us in the question, and I can say this angle BAC is equals to angle DCA. They are alternate angles. Okay. Then I can say AC is common. Okay. AC is equals to AC. So this is equals to this. This angle is equals to this angle. They are alternate and AC is common. So which rule did we use here? We used SAS rule. So by SAS rule we can say that these two triangles are congruent. Triangle ADC is congruent to triangle CBA. So when these two triangles are congruent, I can say DA is equals to BC by CPCT. So when this DA is equals to BC, then I can say as opposite sides, both the opposite sides are equal, then I can say that ABCD is a parallelogram. Hence it is proved. So practice these all the theorems and complete regularly in your classwork.